I would like to give you an overview about the OPTAIN Horizon 2020 project. Then I would like to describe a bit the modeling process, and then give you an example through a Hungarian case study. What are the expected results of the project related to hydrological modeling? So first, let's see the most important information. So this project is led by the Helmholtz Center. They are from Lipcse, from Germany. There are 14 case studies, a few from the Boreal, continental, and Pannonian region, and the partners are we are 20 and from 14 different countries. From Hungary, there are 2 of us. We are cooperating with the General Directorate of Water Management. In this project, it is very important to work together with the stakeholders. We call them MARGE, Multi-Actor Reference Group. So the first thing with which we started to see who are the interested stakeholders in the case studies, and what are the most important problems on the case studies. Then we are dealing with the environmental and socio-economic models. Then, based on the model results, we perform multi-objective allocation and combination analysis. And we are dealing with policy recommendations and building a learning environment where we share information about natural small water retention measures and the model results. And our aim is to create an interactive platform where the users could assess by themselves, if they select different measures, what effects they could get on different sites. So the aim of the project is to assess the effectiveness of natural small water retention measures, and that's why we are using both environmental and socio-economic models on 14 case studies. A little bit about what are the natural small water retention measures. However, I think all of you are familiar with this. So those can be grouped if they are agricultural types or hydromorphological or forestry measures. Since we are dealing with agricultural catchments, we analyze a lot of agricultural types measures like cover crops, min-till, no-till, and crop rotation, green cover. But of course, we have kind of linear measures as well. Riparian forest buffers, also afforestation is interesting. And we have case studies mainly from the Boreal regions where the wetland is also important measures. Then a few slides about the modeling process, which we do in OPTAIN. So in the process-based environmental modeling, we are using catchment scale models and field scale models. For the catchment scale model, we use the soil water assessment tool, and from that we use the latest version. It is actually like further developed for the OPTAIN aim. Since we would like to assess the effectiveness of the measures, we have to perform the modeling field scale. So our hydrological response unit are the fields. So for this, the SWOT model had to be further developed. So a lot of development goes on during the project, which makes some sometimes challenges, let's say. And the point scale model what we use is the SWAP model developed in the Netherlands. And it is interesting to have the SWAP model because we have case studies where we do both scale modeling and we do cross validation with the SWAP model, so with the field scale for the SWAT plus model. So we select HRUs and check how the results are in line, let's say. And the results of the environmental modeling is used for economic assessment. And in this plot, you can see a bit what was the idea in the beginning of the project. More models came into mind, and then we selected one of them for the field scale model. Then a bit more about the SWAT model. So this was developed by the Texas team. Maybe you know them, the Texas A&M University. We are in close collaboration with them. So the SWAT model can provide information about water quality and quantity. And for us, it is a very useful model because we can assess the effect of land use change to change the management, because in the SWOT model you have so-called decision tables where you have the capability to define even the soil management, even if you have data for each field in a time series way. So it is very useful if we can feed the model. An overview about the workflow and the tools we have. So we have 14 case studies, and to be able to compare the modeling results, it's really important to have a modeling protocol and the same workflow which is followed in all case studies. So first is, of course, the input data preparation, then comes the model setup. For the input data preparation, we developed a tool. These tools, which I will mention, all is AirScript based. So this is our working environment. After the input data preparation, we do the model setup. This is supported by two packages, and one of them is called SWAT Farmer, which makes us possible to prepare for as many fields as you have in the catchment, so you can have thousands of them, build a time series management. And with this package, you can consider the climate data you have, so you can fix the date of the management. So you really have a time series that when you plant the crop, when you do different fertilization, soil management, when you harvest and kill the plant. So it helps you to automatize this process, because you know it is a lot of data, several records. And then there is a model setup verification. It is a novelty as well to have a package for that. It is performed by the SWAT doctor. And then we do soft calibration for the crop yield and some water balance elements. And then we do the hard calibration. Both are supported by two packages. One is SWAT Tuner, then the other is SWAT Runner. Then we apply climate scenarios, because we would like to show how effective are these selected measures for different climate scenarios. And then we perform measure scenarios, so we assess the effect of different measures, and then we do combined scenarios. Then a little bit more exact information. So for the Hungarian case studies, among the, let's say, possible measures which were identified by the project, we have riparian buffers, hedges dividing large fields, afforestation, retention, detention ponds, no-till agriculture, and cover crops. we prepare a detailed documentation of these measures in the VOCAT catalog. I don't know if you know this. It can be useful for other projects as well, because there you can find description of specific measures, maybe sustainable management related ones, and you can find information even about the cost, which can be useful as well often. Then we do the environmental and economic assessment. Then we run the multi-objective optimization, and then policy recommendations can be provided based on the results. So this is just to show you that in SWOT, one of the most challenging things is to collect all the data what you need. So you see, if you would like to perform so detailed assessment, field-based, all the managements, you need to gather a lot of data. So in the project, we focused on how to further refine the land use data, because it is not enough that we have arable lands. We have to know what kind of crops are on the arable land, and we need to know time series data. So we were addressing this issue, and also how missing soil properties can be derived. And with this, we can provide soil management information for the model. And just fast picture about, so if we know the time series crop information, then we can assign what kind of specific management are characteristic for a field. Of course, for this we have to discuss with farm advisors, farmers, or whoever can tell us this. Okay, just a fast picture about this is a part of the modeling protocol, how to derive missing soil data. I show it because our institute was leading this, and so here I would like to highlight that we addressed deriving soil phosphorus data as well, and we have a manuscript on this part. Okay, and then let's see some concrete results. I have to tell you that these are preliminary results, so we still have to improve the modeling part. I will show you the results derived for the Tetves case study. This is southern from Lake Balaton in Hungary. So the basic data, I will not go into details because I think you are expert on it. So this is the part of the verification to show you a picture about. So here you can check if your model read the input data, the methodological input data correctly, if it is realistic or not. Then you can assess with this SWOT Doctor verification tool the crop yield. How is the crop yield by the crops what you have in your catchment? What is the crop yield if you do not have any stress? If you have external stress like environmental stress, temperature not optimal, and so on. And if you have both external stress and nutrient stress, how it looks like. So here you can check if your model works correctly. More stress, less yield seems to be logical. And then you can assess the ley development and the biomass development to see if your plants are really growing in the field. So it is just an example about the 3 HRU for some selected years. And this plot is already part of the calibration. Here you can see if the PHU or whatever, so what you need to fix in your model to be the correct one, but it is more meaningful in general. So we have yield data, and we would like to see that the model simulates correctly the yield. And in the Tetves site, we managed to get reasonable data. And this is for the discharge calibration and validation result. So this could be further improved, we know, but let's say we can go on with these results. Then let's see the results. First, the climate change effects. So we used 3 RCPs, the 2.6, the 4.5, and the 8.5. And we have periods, the baseline is 91, 20, 36, 66 near future, 70, 99 end of century. And we consider 6 bias-corrected regional models based on the Eurocordex project. This is altogether 54 model runs. And here are the results. So snowfall, snowmelt, and average soil moisture in the top 30 centimeter is projected to decrease. Then we can check, especially for May, June, July, August, September, how the moisture content will change. Usually it is expected to decrease in RCP 4.5 and especially in RCP 8.5 close to the end of the century. Then the potential and actual evapotranspiration, surface runoff flowing into channels, and lateral soil flow into channels are expected to increase in general. Then let's see the discharge-related data. So average and median flow is projected to increase, except for RCP 4.5 in the near future. Then the minimum daily discharge and the 10 percentile discharge are expected to decrease. Okay, there are some exceptions, so we cannot say that okay for every RCPs it is the same, but for sure the average minimum daily discharge of each year is expected to decrease, and the difference between the maximum and minimum will be bigger and bigger, so we will have more extreme cases. Then what about the water quality? Here in the water quality I have to highlight that till now we managed to calibrate and validate the model just for the nitrate. So for the phosphorus and sediment, these are expected changes, okay, also for the nitrate, but since we couldn't calibrate yet the model for these are less less reliable. So the average nitrogen load of the stream is projected to increase up to 10% at the end of century in RCP 2.5. And the expected trends are different for the other two RCPs. And the average phosphorus load of the stream is projected to increase up to 25% at the end of the century in case of RCP 4.5. The average sediment load is expected to increase up to 30%. And we can say that in general, under wetter conditions in the future, total nitrogen, phosphorus and sediment losses from the land objects are projected to increase. And let's see the crop yield. So it is easier to summarize because for each RCPs and any of the periods we assessed for all crops except the alfalfa, the lucerne, the yield is expected to decrease. Then I will show you now the effectiveness of the natural small water retention measures. So for the Tvetteves site, we analyzed the influence of afforestation, riparian forest buffer, field dividing, and implementing forested buffer strips between the fields. These were applied for those fields which are larger than 50 hectares. Because this is the usual process what is applied in Hungary or like suggested, and no-till management with cover crops. So for the afforestation, I have to say that in the SWOT plus model there is some difficulty to simulate correctly the nitrates. So I would not go into details what happens with this, because what you can see is not reliable. It should not happen. So in this plot, you can see that what is the expected change compared the status quo situation. So status quo means that no natural small water retention measures are applied, but we have the same thing what we have now. And what happens if we apply afforestation for the selected fields? Then high flows are expected to decrease by 16%. Median flows are expected to increase by 2%, so it's just small. Differences between high and low flows are expected to decrease by 16%. Percolation is expected to increase by 7%. Soil water content is projected to increase by 5%. In the period from May to August, the expected increase is even higher, between 9 and 17%. Water quality indicators. So the phosphorus is projected to decrease by 20%, and load is projected to decrease by 5%. Sediment loss is projected to decrease by 50%. Crop yield, it makes no sense to talk about crop yield. Here you can see that in the crop indicators, we were assessing the area of the crops. Of course, if we put forest there is no crop. Okay. Then let's see the influence of the riparian forest buffer. So it has low influence on the water quantity indicators. Water quality indicators are much higher. So all the daily nitrogen concentration, the phosphorus load, and the sediment loss is projected to decrease by 10. Sorry, the daily nitrogen concentration is projected to increase by 10%. And for the crop yield related indicators, no influence on it. Then field dividing buffer strips. The water quality indicators, water quantity indicators are not high. Water quality indicators some percentage in a good direction. And again, this does not have a big effect or influence on crop yield. And finally, we arrived to one management, which does have an important effect. This is the no-till management with cover crops. So its most important influence is on the soil water content, which is expected to increase by 10% on average, and by 12% between May and September. The percolation is expected to increase by 20%, so this is very much in line what kind of information we have from other results or in the literature. Then influence on water quality indicators, again, very positive. The nitrogen and phosphorus loss is expected to decrease, especially the phosphorus loss and the sediment loss. This is again in line with the literature. And on the crop yield, it has a slightly negative effect, and it is also well known by the farmers that it is a less intensive management, so it's normal to have slightly less yield. Okay, so the conclusions. The expected climate change effects are temperature and precipitation increase, nothing new. Potential and actual evapotranspiration, surface runoff increase, again, nothing new. Then it can be interesting that soil moisture in the top 30 centimeter decrease, but okay, it's logical from the above two. Nitrogen and phosphorus loss increase, of course, if the surface runoff increase. And the crop yield will decrease except for lucerne, at least based on our analysis. And as I mentioned, the most effective water retention measure was the no-till management with cover crops based on the measures we were analyzing. And just highlighting a bit the tools that were developed in the project. And some of them were also published already. And where you can find information about the project, we have a Zenodo repository where the protocols and deliverables are uploaded. And we have a project website here, what can be interesting, the case study description, and we started to have webinars, so you can find the recordings on the website. And an announcement that we will have an online March meeting. It will be in Hungarian, so maybe for the Hungarian partners it can be interested. If you would like to join this, please contact me. It will be on the 4th of October. Thank you very much.